In this lesson, we'll be going over the Fibonacci number algorithm. If you're not very familiar with Fibonacci numbers or the Fibonacci sequence, these are very commonly asked about in interview questions, so it's very important to understand what they are. The Fibonacci numbers form a sequence called the Fibonacci sequence, such that each number is the sum of the two previous numbers, and it always starts from 0 and 1. So in this question, we're going to be given a number n, and we have to calculate the nth number of the Fibonacci sequence. For example, if you were inputted 2, you want to output the second number of the sequence, which would be 1, since 1 plus 0 is 1. If you were inputted 3, you want to output the third number of the sequence, which would be 1 plus 1, which is 2. And if you were inputted 4, again, you would be outputting the fourth number of the sequence, which would be 2 plus 1, which is 3. So now that we have a good understanding of the question, let's jump into the pseudocode. The first approach we'll go over today is the recursive approach. In this approach, we will have a method, Fibonacci, with an integer parameter n. We'll have two base cases where if n equals 0, we return 0, and if n equals 1, you return 1. If neither of these base cases is true, you will return the Fibonacci of n minus 1 plus the Fibonacci of n minus 2. So for example, if you were asked to find the fifth number in the Fibonacci sequence, 5 is not equal to 0 or 1, so you would find the Fibonacci of 4 and 3. 4 is not equal to 0 or 1, so you find the Fibonacci of 3 and 2, and then 3 turns into 2 and 1, 2 turns into 1 and 0, 2 turns into 1 and 0 once again, and so on and so forth. While the solution does work, you can see through this map that there are many repeats. As you can see, we're finding the Fibonacci of 3 2 times, we're finding the Fibonacci of 2 1, 2, 3 times, we're finding the Fibonacci of 1 1, 2, 3, 4 times, and so on. So while this solution does work, it does take quite a bit of time, so it isn't the most efficient way to solve this problem. Now, a better approach to solve this problem is to use a loop. Once again, if n equals 0, you return 0, and if it equals 1, you return 1. However, if neither of these is true, all you have to do is use a loop to find every Fibonacci number up to n, and you simply stop once you find the nth Fibonacci number. So for example, if you were passed in 5, all you have to do is find the first 5 Fibonacci numbers in the Fibonacci sequence, which is 1, 1, 2, 3, and then 5. And you can do this with some very basic while loops or for loops and some very basic addition. The code for the solution is also pretty simple. So a and b are the two variables we'll be using to find the Fibonacci numbers, and since we know that a Fibonacci sequence always starts with 0 and 1, a is currently 0 and b is currently 1. These two if statements take care of our base cases, wherein if n equals 0, you want to return a, which is just 0, and if n equals 1, you return b, since that's going to be the first number in our Fibonacci sequence. Now, if neither of the base cases are true, we will create a for loop that iterates from 1 all the way up to n, since we want to find the nth Fibonacci number. We will have another variable c, which is going to equal the sum of a and b, and c is basically our Fibonacci number for this particular iteration. By setting a equal to b and b equal to c, we're incrementing our values so that we can find the Fibonacci number in the next iteration as well. Now finally, once the for loop is over, we know that we found the nth Fibonacci number, which is going to be b, and we can just return that.
Thank you for watching this video. I hope this helped. I'm going to be making many more videos and tutorials on different Python and Java algorithms. So if you're preparing for an interview or you're just practicing coding, make sure to subscribe to my channel, like this video, and leave a comment down below.